Hurricanes are areas of low pressure that bring wind, rain, and destruction. But like all low pressure areas, they follow certain patterns. For example, the wind blows in an anti-clockwise direction round the center of the depression. Let's imagine that the sustained winds round the center of the system are blowing at 100 miles per hour. And let's also imagine that the hurricane system is traveling westwards at 15 miles per hour. This means that in the northern part of the circulation, air will be moving at 100 plus 15 miles per hour, which is the result of adding the speed of the wind and the speed at which the system is travelling. Got it? So the resulting wind, the wind that is felt on the ground, will be 115 miles an hour. Now, in the southern part of the system, the speed of the resulting wind is quite different. The wind is blowing in an easterly direction. It's blowing from the west, the opposite direction to the way the hurricane is moving. So the resulting wind that is felt on the ground will be 100 miles per hour minus 15 miles per hour, or 85 miles per hour. Generally speaking, the strongest winds are going to be at the leading edge of a hurricane, to the north, which is where you will usually find most of the precipitation too. This video shows Hurricane Tomas as it left St. Lucia in October 2010 and headed into the Caribbean Sea. It's very unusual for hurricanes to form, let alone strike, so late in the year, but this time one did. The images were taken by different satellites that measure different things, but you have to admit the pictures are pretty dramatic. But Tomas was different from other hurricanes in another way. Instead of passing over the island fairly quickly, leaving us time to recover and repair our country, Hurricane Tomas decided to stay for a while. The strongest winds, as I just said, are to be found in the eye wall on the northern side of the eye. In the eye itself, the winds are calm, but as the hurricane passes through, the wind changes direction abruptly. In the beginning, the wind might be coming from the north. Then there's a calm period as the eye passes. Then suddenly, the wind blows from the south, which usually means that what the first winds failed to destruct, the later winds destroy, like a knockout combination of a right and then a left. Hurricanes get their energy from the warm waters of the sea. If they move too quickly, they don't have time to suck up energy from the waters below and soon run out of steam. Any hurricane that travels faster than, say, 20 to 25 miles an hour will probably not make it. It will die of starvation. On the other hand, if a hurricane moves too slowly, say less than 15 miles an hour, it will very soon suck up all the energy below it and have nothing more to feed on. It too will eventually starve to death. I always use 15 to 17 miles an hour as a rule of thumb when considering how dangerous an approaching hurricane might become. Between 15 and 17 miles an hour, a storm system has enough time to feed on the energy of the ocean without emptying the larder. This video from the Meteorology Service in Martinique shows clearly how Hurricane Tomas came charging in from the Atlantic and giving Barbados a good licking on its way in. For a while, it seemed that Tomas would go rushing past, albeit over St. Vincent, which would put St. Lucia in the worst sector of all, in the north, where the most dangerous winds and downpours are. Unfortunately, something very peculiar happened. The hurricane stalled, took a little time out, and hung around the east coast of St. Vincent for a while before moving on. And that was when Dennery and Soufrier got the pounding of their lives as hurricane-force winds and torrential rains tore up everything in their paths. There's nothing we can do to prevent hurricanes, but we can be better prepared. And in these times of climate change, we will need to be much better prepared, much more often.